So derivatives are one of the two main keys of calculus. So if you remember, we had a process last time, this chapter, how to do flows, right? What's the formula? Right here, I have a limit of x, h equals 0 of f of x plus h minus f of x all over h. Now we're going to make some simpler ways of doing that. There's a few rules that you're going to know for doing those. So first, some symbols. This is a symbol we use for derivatives. Read it f prime of x, or the first derivative of x. If you want the second derivative, you do f double prime. Third derivative, same sort of thing, 1, 2, 3. And we take the derivative of f of x, or f prime, in order to get f double prime. Take the derivative of this one to get the next one. And after 3, it's typically you start doing something like that. Now, you're probably never going to see those, or very, very seldom, not in this class at all. But first and second derivatives used a lot. Now, the definition, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. That seems familiar. So all of you already probably have the formula for the derivative memorized, right? Now, we have to also, another thing you might see is something like this. Y prime. Yes, that's just saying the derivative of y. Or another thing that's used, dy dx. So this says derivative of y with respect to x. Now, it'd be nice if they be able to have something that says do the derivative of this function or this expression. And we do have it. We have the operator. So the operator for derivative is d dx. What do I mean by operator? Which I think the question somebody had in mind. What is the operator for addition? The plus sign. The operator for subtraction? Minus sign. Operator for a limit is this symbol. So when I say the operator for derivatives is this. So if I said the derivative of y is y prime, this is saying do the derivative of y prime. Just like when we say square root of 4, the square root is the operator, the one that says do something to this function, or to this expression. But the same way with this d dx is the operator that says do something. Everybody follow what I mean by that? No? Okay. When you want something done, you have to tell it to do something, right? If I want to say square root of 9, I have to, if I say I have the number 9, and I want to do something to it, I have to apply something to it, right? Otherwise, you have no idea what I'm wanting. So I could maybe I apply the squares. Now I've done an operator on it. And so what am I supposed to do if I see this? Square. I take 9 times 9. Same sort of deal when I do the square root. It means I want the square root of 9. So when you see this, it's the same thing as saying like the square root, except for not the same operation, it's a different operation. This item that says, if I have this is something we've done with the f of x equals, say, 2x plus 5. If I want the derivative of that, I could say d dx of f of x. What's it going to equal? Anybody know without having worked through the whole process? What? 2. Remember this, we're using this to find the slope, right? So what's the slope of f of x? 2, because it's mx plus b form. Therefore, when I apply this to f of x, I get 2. You with me? So this is just telling us what operation we're doing to this function. Now, we got some rules now. Some of the simple rules of how to do derivatives. First one, probably the one you're going to use the most, known as the power rule. It says if f of x equals x to the n. In other words, we just got like x to the 15 or something like that. Then we put an example down here, f of x equals x to the 15. Then f prime of x equals not 15, n x to the n minus 1. So what is it going to be here? So first, what number goes first? 15. Remember, we take n, put it down front, reduce the power by 1. X to the 14. So if I said, say, g of x equals x to the 7, then g prime will be what? 7x to the 6. Now let's go back and look at this one. What is the power on the x? 1. So, actually I want to, before we go back, let's do one more a corollary to this rule, or an add-on. If f of x equals cx to the n, then f prime of x equals ncx to the n minus 1. So in other words, if we have a number already there, some constant, so f of x equals 6x to the 5th, what would f prime be? Or yes, to the 4th. Okay? So now we've got that. We've got an exponent of 1. We take 1 times 2 is 2. X to the, what reduce 1 by is 0. What's x to the 0? 2. So this combination, so this is actually probably the one you're going to use the most, but it's based on this first rule. Now, a couple more rules we put in here. Well, first, you know what it is. It's f of x, so if f of x equals c, f prime of x will equal what? What? Yeah, let's test something. If f of x equals 5, what does the function 5 look like? Horizontal line, right? What is the slope of a horizontal line? 0. So what it's saying is, if you have a constant, the derivative always equals 0. So if I said the derivative of 5 is what? 0. Derivative of 8. Derivative of pi. 0. So anytime we have a constant, we always get equal to 0 as the derivative. And let's see, it's got a couple more rules, so this is another one. If f of x equals g of x plus or minus h of x, So you've got one function that's basically some other functions added together. And it doesn't matter how many, you could say f of x is equal to g of x plus h of x plus j of x plus k of x. It's just, if we've got several functions together, added together or subtracted together, then f prime of x is equal to g prime of x plus or minus h prime of x. What this means is if you have a bunch of things added together, you take the derivative of each thing individually. So let's say we had f of x equals x to the third plus 4x squared minus 8x plus 12. Okay, derivative. Now, this would be very challenging to do with the limit definition, right? Somewhere you're very likely going to mess up with the multiplication, and it gets really long and hassle, big hassle. What's the derivative of x cubed? 3x squared. What's the derivative of this? Eight x. 2 times 4 is 8, reduce the power by 1. Minus 8. What's the derivative of 12? 0, so I don't need it. So, notice this basically took the power of x and reduced it by 1 for each section going across. 3x squared plus 8x minus 8. We follow where those numbers came from.
Power rule?
This is still the this is the power rule, and then applying these other parts as well. Now the complicated one. Got two more rules, but they're a bit more complicated. First one, product rule. What do you think this deals with? Multiplication, yes. So, if f of x equals g of x times h of x. Now, addition was really easy, multiplication not so much. Then, f prime of x. The derivative, so g prime times h plus h prime times g. So, f of x equals, let's say, 12x cubed times, say, 4x squared plus 5. So, no, we could distribute this out and get it that way. However, I want to do a demonstration of the product rule. First, which part would be g of x? Okay, so let's call that g of x. This would be h of x. So, first, what's the derivative of g of x? 36x squared times h of x plus derivative of h of x. 8x times 12x cubed. So 36 times 4, 72, 144, x to the fourth, 5 times 36, plus 180, x squared, 8 times 12, 80, 96, the fourth. Combine these, 96 times 144, say 244, 240.
Is this f prime of x, or?
Yeah, f prime, so I should put that there. So 180x squared. Now, in this case, it probably would have been easier to just distribute this out, right? And then do derivative there. When might this be more difficult? Yeah, so if I had, say, 3x cubed plus 5x plus 1 times 2x to the fourth minus 6x cubed plus 5, and we're taking the derivative of that. You want to multiply it first, or... Anyway, this one might be about equal difficulty, either way. Product rule is signed when we get to things like taking derivative of sine of x. So x squared times sine of x. And the last of the rules, quotient rule. If f of x equals g of x over h of x. What restriction do you think we have to place? Yeah, h of x does not equal 0. I'm not going to write it, however, you should make sure you're remembering that. It could be an issue. Anybody have a guess what the derivative is going to look like? Okay, so g prime of x, h prime of x, minus, or not h prime, sorry, g prime of x, h of x, minus Notice it is very similar to the product rule, except for then you've got a denominator. Let's say we had f of x equals 16x squared plus 5x minus 7 over x plus 2. And I want the derivative of it. First, where would this not apply? Yeah, x cannot equal negative 2 for this. So f prime of x. We say take the derivative of the top, which is going to be what? See, 32x plus 5 times the bottom minus derivative of the bottom, which is 1 times the top, 16x squared plus 5x minus 7 all over x plus 2 squared. Now for a problem like this, there's not really, this is, I think, the easiest way to do it. So it's not like, with the product rule you can distribute it out and do it. This one is not really something easier. So, 32x times x gives us 32x x. So 32x squared minus 64 plus 64 plus 5 plus 69x plus 10 minus 16x squared minus 5x plus 7 all over x plus 2 squared. Combine my terms. Here, those two, 69 minus 5 plus 64x plus 17. And most of the time, you probably want to leave it as just x plus 2 squared instead of multiplying it out. Now there's one more theorem. So I've got all the rules, now I've got a theorem. And this is a fairly straightforward theorem. the extreme value theorem. What do you think extreme values mean? When we talk about extremes, what does this mean? When we talk about extremes of a function, what would this mean? What? Maximum or minimum. So when we talk about extreme value theorem, it deals with maximums and minimums. So if f is continuous on a b, then everybody have an idea what continuous means? No breaks in it, no discontinuities. It's defined everywhere. You don't have any of these shooting to infinity things. So from A to B, then f of x has a max and min on AB. So if it's continuous, then somewhere in there there's a highest point and somewhere there's a lowest point. Would that make sense if that would be the case?
Yeah.
Now, it doesn't mean that there is only one maximum or only one minimum. So in other words, you could have something that does this and goes up and does the same height. So you'd have two maximums, but there is a maximum. There's also a minimum. Now, what if you had a graph that looks like this? And you're going from, say, let's say this right here is A, and this is B. Where would the minimum be? Okay, what? Yeah, the minimum would be here at A. So the endpoint could be a maximum or minimum. Highest point or maximum there. Now, this does not tell us anything about what's happening in the middle. It just says if we've got a continuous line, continuous curve, there is a maximum and a minimum between these 2 points, including the point, as it says.
So when it says f, what does that mean?
Some function, f of x. So oftentimes you shorthand, say, instead of putting f of x, just put f, the function f.